All right, we're going to solve 3 derivative problems, and all 3 of them require the chain rule, so let's write that over here. I'll write it in the form the derivative of f of g of x equals f prime of g of x times g prime of x. The derivative of a composition is the derivative of the outer function evaluated at the inner function times the derivative of the inner function. So in our first example, we have the sine of the inverse tangent. Sorry, it's not an inverse. The tangent is the inner function. We have the sine of the tangent of x, and the tangent of x is the inside function. The sine is the outside function. So according to the chain rule, to calculate this derivative, we calculate the derivative of the outside function, and that's the cosine. We leave the inside function in. We want the cosine of g of x. That's the cosine of tangent of x. And then times the derivative of the inner function. The derivative of the tangent is secant squared x. For the second one, also a composition, we have an inner function, which is x times log x, and we have an outer function, which is again the sine function. So let's look at this formula explicitly with the sine function as the outer function. So this formula applied to the sine function as f says the derivative of the sine of g of x is equal to the cosine of g of x times g prime of x. That's what we had here, the cosine of g of x times g prime of x. So we'll do the same thing here. It's going to be the cosine of g of x, which is x times the natural log of x. And then we need times the derivative of g of x. Now, this time, g of x is a complicated function. It's not just a basic function, it's a product. So the derivative of g of x is going to require the product rule. So here's the product rule, and we apply that to x ln x. So we have the first term here, the first factor, cosine of x ln of x, and then times the derivative of x times ln x from the product rule. The u is x, so u prime is 1, I won't write that, times ln of x, and then plus x times the derivative of the natural log of x, which is 1 over x, and here x times 1 over x cancels, and that's just equal to 1. So in the brackets, it's just 1 plus natural log of x. So we could write it as cosine of x ln x times 1 plus ln x. So we had a product rule within the chain rule. We were doing the chain rule, and when we got to the derivative of the inside, the last part of the chain rule here, the g prime, we had to use the product rule because the g of x in this problem was x times ln of x. So to calculate g prime of x, that requires the product rule. So we had to use the product rule within the context of the chain rule. And the same thing happens in this problem. We have derivative of natural log of x cosine x. So we can do the same thing we did here. We have an inner function, which is a product. It's x times cosine x. And we have an outside function, which is the logarithm. So to do the chain rule with the logarithm, if f of x is equal to the natural log of x, then f prime of x is 1 over x. And the chain rule requires f prime of g of x. So f prime of g of x is 1 over g of x. We simply replace the x here and here with g of x in the same two places. So the derivative of the outer function is the log. So we're going to get 1 over, and then the inside is x cosine x, because we need 1 over the inside function. The g of x is the inside function, so the derivative of the log in such cases is 1 over the inside function. And then times the derivative of the inside function, and this one again requires the product rule. So we have 1 over x cosine x, just copying that one, times, and now this derivative from the product rule is 1 times the cosine of x plus x times negative sine x. And I will write this as just negative x sine x. So we have a fraction with x cosine x on the bottom, and we have cosine x on the top, along with minus x sine x. So there's an answer. And I'm really tempted to do some canceling here, canceling a cosine, canceling an x, but I can't cancel with this subtraction in the numerator. So what I'm going to do is I'm going to split this into 2 fractions. I'm going to write cosine x over the denominator, and then minus x sine x over the denominator. Now I can cancel. Cosine x over cosine x is 1 over x. So that's, cosine x over cosine x is just 1. And there's an x on the bottom there. So we get 1 over x, and then minus x over x cancels, and we get sine x over cosine x, which is tangent of x. And so this is another form for the answer, which looks a lot simpler than this complicated conglomeration of x's, sines, and cosines. So that makes me question, was there another way to handle this problem to get that answer directly? And the answer is yes. And I'd like to look at that using a property of the logarithms that has nothing to do with derivatives. The property is the natural log of u times v is the natural log of u plus the natural log of v. So this original problem, the natural log, this function, natural log of x cosine of x, could be rewritten as the natural log of x plus the natural log of cosine of x. And then if we take the derivative of natural log x, we get 1 over x. And if we take the derivative of natural log of cosine x, well, evidently we should get negative tangent x. Let's just check that one. Let's look at the derivative of the natural log of the cosine of x. So we have to use the chain rule. The derivative of the log is 1 over, leave the inside in, and then multiply by the derivative of the inside. And indeed, we get negative sine over cosine, which is negative tangent of x. So that's a second way to look at it. Using this property of the logarithm, we could turn this product that's inside of the log into a sum of logarithms, and then we have basically one derivative here turning into 2. And they're both simpler than this original one that required the product rule. And we end up with this nice simple form of the answer if we use the log property.